Now for this last section in Module 14, we are going to talk about segment relationships in circles. Some of our segments will be inside the circle, some will be outside, some will be right on the edge. So for this first one, if we have two segments that intersect inside our circle, and notice it's not in the center, the intersection is not the center of the circle, so just anywhere in there, so two chords, that we can set up an equation to find the missing pieces. And what it is we can, if we multiply the two pieces together, and I multiply the other two pieces together, that the product of both of those will be equal to each other. So here's my general setup I set up, or I put on my paper. So piece times piece equals piece times piece. And this is what it would look like for our equation. So in number one, we're going to use that to set up an equation to solve for the x. So I can set up my two pieces multiplied together. So I'm going to take my 6 times the 2, so for these two pieces, and then those will be equal to the other two pieces multiplied together. So my 3 times the x. So this means we've got 12 equals 3x, so x is going to equal 4. Now pay attention to the directions. Here is find the length of both chords. So it's not just the x, it's the whole length of the chord. So AB will be everything together. So if this piece is 4, then that is 7 altogether. And then CD is our whole length, so 6 plus 2 is 8. Before we get into the other formulas of how we can use our chords and set up products to solve for different pieces, we have a few more definitions. And the first one is a secant. So if you look at your picture right here, the secant is any line that intersects a circle at exactly 2 points. So it's basically a chord that's going to keep going outside your circle. So one of those would be AE, and the other one would be CE on the other side. So both of those are secants. A secant segment then is just part of a secant line with at least 1 point on the circle. So it's the two pieces that make up that secant. It would be AB and BE, and then for the other secant would be CD and DE. To be more specific, the external secant segment, so remember your secant segments are these two pieces, so it includes all of them. The external secant segment then is just the outside piece of that. So it's a secant segment that's outside the circle with 1 point on the circle. So that would be my DE and BE. Remember, the reason we went through these definitions is because some of the following formulas that we're going to be using is going to use this language in there, and you want to know what pieces they're talking about. So for secant products, we have two secants going through our circle. So look at my picture right here. That if our two secants intersect outside the circle, so at point A, then the product of the lengths of one secant segment, so the lengths of those secant segment and its external segment, so that'd be the whole piece versus just the outside piece, will equal the product of the whole length of the segment, of the secant segment, and its external secant segment. So this is my definition that I put in more of a general terms. So you can take the outside piece and multiply by the whole length, and the outside piece times the whole length. So look at what I did up in my example up here. So my outside piece is the BE, and then times the whole piece is AE. The outside piece for the second part is DE, and then the whole length is C to E. So realize you might have to add some pieces together to give you that whole length of the secant. So in number 2, we have to do the same thing. We want to set up our outside times the whole thing, and then the outside times the whole thing, and they're set equal to each other. So first off, I've got my outside pieces there, but the whole length of this purple is really going to be x plus 5 because I need to add those two pieces together. So when I solve this, I'm going to have to distribute that 5 to simplify it. For this red-orange color, the whole length over here will be 6 plus 6, which then in turn will be just a 12. So when we go ahead and multiply this, our 6 times 12 is 72, so let's do that side first. Then on the left side, we have to distribute, so 5x plus 25. And now we need to solve for x, so we get to subtract our 25 from both sides, and we get 5x equals 47, and we got to divide both by 5 to get rid of the 5, and we get x equals 9.4. Now realize that that's okay if we get a decimal number, sometimes that will happen. So we need to find the value of x, plus we need to find the whole length of the segments. So I need to find my AC, and that's this whole part in purple. So I need to take 9.4 plus the 5 to give me that whole length, and we will end up with 14.5. All right, so then for the other secant segment was AE, and that one we already found really before because it's this 12. So that one's a little bit easier. Now for this last one, we have a tangent and a tangent segment we need to talk about. So usually a tangent is just our tangent line outside, and it's a line that keeps on going, but touches just one side of your circle. But a tangent segment means that it has only one point on our circle, but it's just a piece of that tangent line. So if you notice, it stops at our point where it crosses our circle. So if we have this picture, we have a way we can set this up to find the length of a missing segment. And if you notice, it's just a secant and it's a tangent. But I treat it the same way as this over here because it works the same way. So if I have the outside piece times the whole length, and we have the outside piece, but that same piece is the whole length, and that's where this tangent ends up being multiplied by itself because it's the outside piece and it is the whole piece. So let's go ahead and do number 3 for our last one. So we have the outside piece times the whole length, and here is 10 because we can take our 6 plus 4 to get that. And then we have the outside piece, which is our x, and we have the whole length is still the x. So that's where we get x times x. So we get x squared. Don't forget it's x squared, not 2x. So just be careful of that. 4 times our 10 then is our 40. And to solve this, we have to take the square root on both sides. So the square root of 40 is going to be, if we want to write this as our reduced radical, we got to make sure that we break this down. So we can do 4 and 10. We have 2 and 2, so there's a pair of 2's, and 2 and 5. So remember, my 2 goes outside, and then this 2 and the 5 that are left over need to be multiplied back together. So my x value is going to equal 2 square root 10. So that's my x. I need to find the secant segment, and my secant segment is already found since that's my part in purple right here. And so our secant segment then will end up being a 10, and then my tangent segment, since we might as well fill that one in as well, will just be this 2 square root 10. So remember, there's really only 2 different ways you can think of this. If you have your segments that are inside your circle, you are taking your piece times piece equals piece times piece. If you have segments that are outside your circle, whether there's 2 secants or there's a secant and a tangent, I think of it as this way right here, where we have the piece, outside piece times the whole equals your outside piece times the whole, because that's really the same thing as what this is representing, and then you have one less formula you need to remember.